Within the place of technology and giant mysteries, the problem of what existed before the significant explosion has sparked conversations and intrigued thinkers for quite some time. This massive question does not just test how we ought to decipher the universe, it challenges the true furthest limits of human expertise. Consider standing at the threshold of existence, gazing into the vast unknown and wondering what lay there before our universe was imagined. The event of the Big Bang marked the beginning of time, space, and all that we know. But was there a second before this? Could there have been a state of nothingness, a peaceful calm before the cosmic gathering began? And if this is true, was it really nothing, or was there something much more alarming that existed before time itself? As we dive further into this question, science takes us on a journey beyond the universe's starting point, into ideas that challenge our perception. Physicist Brian Cox, known for his investigation into the wonders of the universe, suggests that something unexpected might have existed before the vast detonation. He urges us to rethink our ideas of reality and life. In this exploration, we'll dissect the science, the hypotheses, and the marvelous secrets that might explain what existed prior to all that we know. We will explore concepts like self-organizing development, quantum fluctuations, dark energy, and even multiverse. The answers we've discovered might paralyze you with awe, but they could also open new understandings of our place within the cosmos. Get ready to dive deep into a world beyond imagination and science, where the unknown still whispers through the shadows, leaving scientists stunned, and sometimes even disappointed. We must explore what existed before the Big Bang, and why the theories surrounding it challenge everything we thought we knew. To appreciate what may have existed before the Big Bang, we must first painstakingly analyze what the Big Bang truly was. The Big Bang, as scientists define it, refers to the moment when the universe became extraordinarily hot and dense, expanding rapidly to initiate the formation of all matter, energy, and fundamental forces. When we look toward the night sky, we see evidence of this fiery beginning, galaxies spreading out in all directions from an early central point. But why did this happen? Moreover, was there a period before this thick, hot start? According to the theory of cosmic inflation, there was a time before, and it wasn't a void or peaceful nothing. Inflation theory suggests that before the Big Bang, the universe existed in a state that was cold, empty, and free, like a vast vacuum. But this vacuum wasn't completely empty. It contained an immense amount of energy that fueled the rapid expansion of space itself. This expansion, known as inflation, occurred so swiftly that it essentially laid the groundwork for everything that followed. Space expanded at unfathomable speeds until the energy transformed into matter, particles, and the forces we now recognize as the Big Bang. But what was the nature of this energy? Why did it create the universe, and why did it stop? Experts believe this immeasurable inflation created patches of the universe, each experiencing its own Big Bang. Imagine an endlessly stretching fabric, with tiny air pockets forming here and there, each pocket representing a universe, including our own. This idea, known as the inflationary multiverse, suggests there are likely countless Big Bangs and an infinite number of universes. Ours is just one among many. This massive, mind-bending reality challenges our understanding of the universe itself and leaves us with the question, what else is out there? The idea of nothingness before the Big Bang is speculative, not proven, based on our current understanding. Even if you removed all matter, energy, and radiation from the universe, it still wouldn't be truly empty. Our universe is full of dark matter, dark energy, quantum fields, and invisible forces, all part of an unavoidable cosmic fabric. Even in its most vacant state, the universe still cannot achieve complete nothingness. Space itself has properties, rules, and constants that prevent it from being utterly empty. Imagine trying to create a place with literally nothing, no particles, no radiation, no energy. Yet, quantum fields and fundamental constants would still remain. This suggests that even nothingness has properties. For example, there's a concept called zero-point energy, which represents the lowest possible energy state of quantum fields. In this state, particles can still momentarily appear and vanish, creating a ghostly hum of activity in what should be empty space. This challenges our idea of a true void and suggests that yes, even before the Big Bang, something existed, something scientists are only beginning to understand. One of the most remarkable theories in modern cosmology is the possibility of eternal inflation. If inflation could create our universe, it's possible it continues, forever. Brian Cox describes an astonishingly vast inflationary multiverse, where new universes are constantly being born and continue expanding. Imagine each Big Bang as a spark lighting another universe, while inflation continues in other regions, making countless others. This cycle could, in principle, go on eternally. The idea of infinite universes leads to the concept of a fractal universe, in which each new universe might eventually generate its own Big Bang. Each universe exists as a separate, independent domain, unaffected by the others due to the rapid expansion of space. For scientists, this theory is both thrilling and terrifying. It suggests an endless multiverse with no true beginning or end. Imagine our universe being just one pixel in a colossal, ever-expanding cosmic pattern, always generating new realities. And what if the startling truth is that there is no before or after, only a timeless pattern of universes forming and decaying? If early-stage gravitational waves can be traced, they might reveal patterns or anomalies that challenge the conventional timeline of the universe. They could expose evidence of a collapsing universe before ours, or of strange fluctuations in the quantum fabric, suggesting events prior to the Big Bang. In this way, gravitational waves could act like a fossil record, echoing from a time we believe didn't exist. But what if even this isn't the beginning? Some scientists explore the concept of quantum loop gravity, a theory suggesting that spacetime itself is made of tiny loops, not continuous as we once thought. If this is true, it could mean the universe didn't begin from an infinitely small point, but rather bounced from a previous universe that collapsed. This is called the Big Bounce. According to the Big Bounce theory, the universe we inhabit now might be the result of another, older universe that reached maximum contraction, then rebounded into a new phase, our phase. Just as a compressed spring recoils, spacetime could rebound after collapse, bringing forth a new cosmos, with new rules, matter, and dimensions. If so, then time never started. The universe was never born, it simply changed form, infinitely. Imagine that instead of a beginning and end, the universe breathes. It expands and contracts, lives and dies, eternally. There was no moment of true creation, only a cycle, a cosmic heartbeat that beats far beyond human comprehension. This idea doesn't just challenge physics, it strikes at the heart of philosophy, religion, and existence itself. Because if there was no beginning, what does that say about purpose? About origin? Are we the product of chance in an endless loop, or is the universe learning, evolving with each bounce, becoming more complex, more aware? And where do we, humans, thinkers, explorers, fit into all of this? The search for what came before the Big Bang isn't just scientific. It's emotional. It's spiritual. It's existential. We're not just asking about time and space, we're asking, why are we here? As we stretch the limits of our knowledge, peering deeper into the past, we may never find a clear answer. But in the search itself, in the reaching, questioning, and imagining, we uncover something even more profound. That the universe, in all its mystery, reflects the very core of what it means to be human. To wonder. To not know, and still seek. A glimpse into the cosmic kingdom. Earlier than our universe was born, this principle gives a tantalizing prospect, detecting gravitational waves that could act as fingerprints of a pre-Big Bang universe. As we continue to explore what might have existed before the Big Bang, we delve into ideas that push the limitations of our knowledge, challenging even our most fundamental assumptions about space, time, and existence itself. One of the most mind-boggling ideas comes from the realm of quantum gravity, a field that seeks to merge quantum mechanics with general relativity. This merger could potentially reveal a unified theory of everything and might provide insight into what existed before the Big Bang. Quantum gravity suggests that space and time are not smooth, continuous entities as we experience them, but rather are discrete, granular structures. This theory posits that the fabric of spacetime itself might have been formed from a microscopic Planck-scale structure, with tiny quantum fluctuations shaping the universe in ways we cannot yet fully comprehend. In this view, what we perceive as the smooth continuum of space and time might have only emerged from these fluctuating quantum fields. Therefore, the before the Big Bang may be explained through a radically different concept of reality, one in which space and time themselves were not yet fully formed. Another possibility is that the universe is part of a vast cosmic landscape of possible universes, each with unique physical laws and constants. This theory, called the string landscape, arises from string theory, which suggests that all fundamental particles are actually tiny vibrating strings. In this framework, there are many possible configurations of these strings, each corresponding to a different set of physical laws. The string landscape could imply that our universe is just one of many, each emerging from its own distinct Big Bang-like event. The existence of such a landscape also brings forth the notion that other universes might have different dimensions, different strengths of gravity, or even different types of matter. In this view, our universe may not be unique but instead part of a multiverse, a collection of universes, each evolving independently. The multiverse concept offers a speculative yet fascinating answer to the question of what came before the Big Bang, another universe, in a unique configuration, potentially leading to endless cycles of creation and destruction, without a definitive origin. In addition to these cosmological models, some theoretical physicists have also considered the role of black holes in shaping the nature of the universe. A hypothesis gaining interest is that our universe may be the result of a black hole formed in another universe. In this scenario, the singularity at the center of a black hole could serve as a gateway to another universe, with the Big Bang being the moment when such a black hole gave birth to our cosmos. This hypothesis is supported by the fact that, according to general relativity, the singularity at the center of a black hole is a point where space and time curve infinitely, creating a region where the known laws of physics break down. It is possible that the extreme conditions inside black holes could lead to the creation of new universes, suggesting that what we consider the Big Bang was simply the birth of our universe from the singularity of an ancient black hole. Exploring these ideas requires a deep dive into the very nature of time itself. Some cosmologists speculate that time, as we understand it, might have had no meaning before the Big Bang. If time began with the Big Bang, then there may have been no before in any traditional sense. According to this view, time itself might have emerged from a quantum fluctuation or from a primordial state in which the usual distinctions between past, present, and future did not apply. This would lead us to reconsider the concept of causality, which relies on the idea that events occur in a linear sequence. If time did not exist in the way we experience it, then the question of what came before the Big Bang becomes nonsensical, as there would be no temporal framework to support it. Further complicating the picture are theories of cyclic time. As mentioned previously, cyclic cosmology suggests that the universe undergoes endless cycles of birth, evolution, and eventual collapse. In this model, the Big Bang could represent just the most recent bounce in an eternal sequence of universe cycles. These cycles might not be identical but could evolve in different directions, each with distinct physical properties. The cycle of the universe, according to this idea, would be a continuous process with no true beginning or end, rendering the question of before the Big Bang meaningless in the conventional sense. The idea that time itself might be cyclical suggests that each Big Bang could be followed by a contraction and another big crunch, with the universe reinitiating itself in an infinite loop. Another avenue of research into the nature of the cosmos is the potential of a primordial soup of particles and fields that existed even before the formation of stars and galaxies. This concept suggests that before the universe began its rapid expansion, it was filled with a dense and hot mixture of elementary particles, such as quarks, leptons, and bosons, all in a state of intense energy. These particles might have been interacting at very high temperatures and densities, laying the foundation for the formation of matter and energy as the universe cooled. Some versions of this theory propose that this primordial soup existed in a quantum foam, where particles continuously emerged and vanished due to the uncertainty principle of quantum mechanics. The properties of this soup could potentially offer insights into the universe's earliest moments, and, by extension, what preceded the Big Bang itself. In the end, what existed before the Big Bang remains one of the most profound mysteries in science. As our understanding of quantum mechanics, cosmology, and fundamental physics deepens, new theories will continue to emerge, providing increasingly complex and sometimes paradoxical explanations for the origins of our universe. While we may never fully grasp what came before the Big Bang, the pursuit of this knowledge will continue to stretch the boundaries of human curiosity, driving us to explore the unknown frontiers of existence. This relentless pursuit of understanding, of peering beyond the veil of the observable universe, has become one of the most ambitious undertakings in modern science. It bridges not only physics and cosmology, but also philosophy, as we wrestle with questions that challenge the very framework of human perception and logic. As scientists develop more sensitive instruments, such as advanced gravitational wave detectors, cosmic microwave background analyzers, and quantum field simulators, we inch closer to glimpsing the imprints of pre-Big Bang phenomena. These tools might one day detect minute anomalies or echoes from an earlier state of existence, offering empirical clues that move these ideas from speculative theory into observable reality. Yet, for all our technological advancements, there remains an intrinsic limitation. We are creatures born within time, attempting to comprehend conditions where time itself may not exist. This paradox lies at the heart of our inquiry. If the origin of the universe is indeed a boundary where classical logic dissolves and quantum uncertainty reigns, then our journey may not yield absolute answers but rather ever more profound questions. Some theorists argue that understanding the before may require an entirely new paradigm, one that transcends current mathematics and language. Concepts like nonlinear time, emergent dimensions, or pre-geometry have been proposed, suggesting that what we perceive as fundamental might itself be a byproduct of deeper, still unknown laws. Others take a more metaphysical route, suggesting that perhaps the quest for a beginning is misguided, that the universe, or multiverse, simply is, without origin or end. In this line of thinking, existence is a brute fact. It doesn't arise from anything, nor lead to anything else. It just exists, cycling through endless expressions of energy and form, beyond cause and beyond comprehension. Still, this does not deter the human spirit. The very act of questioning, of daring to explore what lies beyond the birth of space and time, is a testament to the curiosity that defines us. It is the same drive that once led us to map the stars, to cross oceans, and to unravel the double helix of life. In seeking what came before the Big Bang, we are not merely trying to understand the cosmos, we are, in a sense, trying to understand ourselves. Our place in the grand narrative. Our connection to the infinite. And perhaps, in that search, we may one day discover not just the secrets of the universe, but the deeper truths of what it means to exist at all.